Microservices in AIML. Definition: a software architecture style that structures an application as a collection of small, independently deployable services, each serving a specific business function, tailored for AI and milliliter applications. Key components: services, self-contained units that implement specific functions of the application. APIs, interfaces that allow communication between microservices, often using REST or gRPC. Data stores, databases or storage systems that individual microservices use for persistence. Orchestration, tools and frameworks that manage and coordinate microservices, such as Kubernetes, monitoring and logging, systems to track performance and errors, providing visibility into microservices operations. Benefits: scalability, allows individual services to scale independently based on demand. Flexibility, facilitates the use of different technologies and frameworks for different services. Resilience, improves fault isolation, preventing the failure of one service from affecting the entire application. Speed of development, enables parallel development and deployment by different teams. Maintenance, simplifies updates and bug fixes, as changes to one service do not require redeployment of the entire application. Applications in AIML. Model training, dedicated services for training machine learning models. Model serving, microservices that handle the deployment and inference of trained models. Data preprocessing, services that clean and transform data before it is used for training or inference. Feature engineering, microservices responsible for generating and managing features used in models. Monitoring and metrics, services that track the performance and accuracy of deployed models. Experiment tracking, microservices that log and manage experiments, including hyperparameter tuning and version control. Tools and technologies. Containerization, using Docker or similar tools to package microservices for consistent deployment. Orchestration platforms, Kubernetes, Docker Swarm, and other platforms that manage containers and services. Messaging queues, Kafka, RabbitMQ, and other systems for inter-service communication. CI/CD pipelines, Jenkins, GitLab CI, and other tools for continuous integration and deployment. Monitoring tools, Prometheus, Grafana, Elk Stack, and other tools for observing microservice performance. Challenges: complexity, managing numerous services and their interactions can be challenging. Data consistency, ensuring consistency and integrity of data across services. Latency, potential performance overhead due to inter-service communication. Security, implementing robust security measures for inter-service communication and data handling. DevOps, requires advanced DevOps practices for effective deployment, scaling, and management.